And so we are looking at electrolytic cells. So electrolytic cells contrast with galvanic cells. In a galvanic cell, you have an active metal that gives up its electrons to a less active metal, or one that has a greater affinity for electrons. And you can actually produce voltage with this and make a battery. In fact, that's how batteries work. Electrolytic cells, on the other hand, we actually use electricity to move electrons from one thing to another. We were looking at the graphite electrode electrolytic cell. So basically, graphite is, in fact, although it's a form of carbon, it is an allotrope of carbon and it's a conductor. And so we can use it as a nice neutral electrode. We put it in copper sulfate solution. What we're hoping to do is reduce the copper ions in the copper sulfate solution to get copper metal. At the anode, though, there has to be an accompanying oxidation. There has to be a source of electrons. So let's take a look at what the cathode reduction looks like. We have copper 2+ ions. What we are expecting to see are 2 electrons added to that aqueous copper. And we are going to see this turn into solid copper. That's what we are expecting to happen. But what is happening at the anode? So carbon is not actually being oxidized. We won't actually see carbon coming out into the solution. Instead, the water that makes up the solution is going to be the product of the oxidation. So water, which is hydrogen and oxygen, if we look carefully at those electrodes, what we're actually going to see is we're going to see a little bit of oxygen gas forming. So we should actually see bubbles on that electrode. And the second thing that we should be seeing is, that we won't actually see, that will happen, is we will get hydrogen ions formed. And there's going to be an electron coming off this hydrogen ion. Now, notice I have to balance this equation. So I've got 2 hydrogens, which is going to give me 2 hydrogen ions, and it's going to give me 2 electrons. I only have 1 oxygen, and I have an O2 over here. I'm going to fix that just by adding a 1/2 in front of my O2, mostly because the electrons nicely balance. Okay, so to reiterate, here's what's happening at the cathode. Reduction. 2 electrons are added to copper ions. We produce solid copper. Here's what's happening at the anode. We're getting oxidation. The oxidation is actually happening to the hydrogen atom in H2O, and we're getting hydrogen ions released into solution, so it should get a little more acidic, and this is where the 2 electrons are coming. Now, remember how we took net ionic equations and we added them together? That's what we're going to do here. We have 2 electrons on this side of the half reaction. We have 2 electrons down here. And we're going to add these 2 reactions to get the overall cell reaction. So on the left side, we have copper 2+ ions plus water. And that is going to give us solid copper plus oxygen gas plus hydrogen ions. That's my overall reaction.